Hi guys, and welcome back to another development video. So this time we'll be actually looking at making it so that these projectiles that we fire actually collide with things. And currently they just travel in a straight line and they go through everything, and they're consequently also never destroyed, never removed from the world. And so I thought about it a little bit, and I'm not exactly sure how I want to handle the collision detection in the final game, but I think at least for now we'll use raycasting just to kind of get started with something. So if we look at the game like this, a pretty easy way for us to actually determine if something is if one of these projectiles is hitting something is to fire a ray from the nose of the projectile forward in a straight line, and seeing which object it hits, if anything. And that also gives us the information about the distance to the hit. So since these guys will fire rays every tick, they will essentially always hit something currently because the level looks like this. We have these borders, these edges of the level that they will always hit if they don't hit anything else before that. So we need to check when the ray hit is close enough to the actual projectile, and then we'll register a hit. And also that the raycast will tell us which object we hit. So if we hit like a piece of the environment, we'll just destroy the projectile, and if we hit an enemy, then we'll apply some damage and perhaps kill the enemy off. So I think we'll start with that, and then later on we'll see if that becomes too heavy, then we'll have to figure something else out. But that's gonna be pretty easy to set up now for this game, I think so. And one more thing related to that, I think what will actually be casting are not rays, but actually sphere shapes. So if we look at the physics scene here in C++, we have a bunch of these Raycast methods here, and a raycast is essentially just like an infinitely thin line, just like these lines here, infinitely thin line of whatever length we tell it to be. And so that would work, but it might miss some objects that would actually hit the projectile, because the projectile obviously has some thickness. So we're not actually going to use these. We'll use the sphere sweep instead, which you can imagine as like the sphere here, for example. If you took it and then you moved it in this direction, and you kind of register the first thing that it hits if it moves in a straight line, and that is the sphere sweep. So let's do that next. I started a little bit with exposing the sphere sweep to Zig, because I wanted to kind of explore that a little bit before I started the video. So the shape class is actually not the shape, the scene class is pretty simple currently. We can actually only ever do forces currently in the Zig version, but I actually I went ahead and started working on this sphere sweep. So we have the binding already set up for us, and let's see what it looks like here, and then we can implement the actual function in the Zig struct. So it looks something like this. So that's a CPP pointer. We can ignore that for now. So we'll give it a radius, we'll give it an origin and a direction, and they're both vector trees, and then a distance, max distance, which will just make something large now, so that it's essentially, for all intents and purposes, it's an infinite ray or sphere sweep. But let's just call it Ray for simplicity. And it gives us this Raycast result struct, and also returns true or false whether it hit anything. And the Raycast result looks like this currently. So we'll make a struct for this in Zig as well, so that we have a nicer struct there in the actual Zig code. So I still can't do block comments in Zig like that. And the Raycast result gives us the hit point in world space of the hit, and the normal, and the distance from the beginning of the ray to the hit, and then finally it gives us the hit object name. Oh, that's actually, yeah, that's supposed to be actually hit game object name hash. So let's change that. I added this like 10 minutes ago or something, so it's not used anywhere yet. Yeah, so game objects such as let's just have a quick look. Oh, okay, we'll need to rebuild now because I changed the header. That's annoying. And yeah, we are already filling it in on the CPP side. So game objects in the world all have unique names, and this is something that we talked about briefly earlier when we were actually when we were spawning objects. And that's important because of various things. So let's just play and then pause. Come on, pause the game. And you can see, oh, it's called Coolio player for some reason. But yeah, we have names for all of these guys. Some of them are placed in the level editor. Currently, you can typically see those objects. They're separated by this colon. So this is a layer name, and this is the actual object name. And together, they form like a unique identifier for this block here. Projectiles also have, so they have object, and then we have like a randomly generated, not randomly exactly, but uniquely generated prefix here. So yes, this is the object's name, and typically if we want to identify an object at runtime, we don't use its name, but rather its name hash, which is a 32-bit hash of that name. The reason being that it's much smaller to pass around, and you can pass it around over the network and whatnot. So now that we actually had a look at that, let's see. The names were a little bit silly. So yeah, so I think that was my test when I originally just started trying out the Zig player spawning. So now it's supposed to be just player and then the spawn point index. So it would be player 0, not Coolio player 0. And for the actual enemies, right? Yeah, they're just called object, and then the random string at the end because of this essentially, and the projectiles as well. That's fine. Let's keep it that way. Okay. Anyway, so if we get back to this, so this will give us the name of or the hash of the hit game object, or 0 if it wasn't actually a game object that was hit, because these raycasts are they're actually not hitting objects in the game object sense, but rather physics objects. And then the Zig call that I did earlier today just actually figures out based on the hit actor. It's right here. So it figures out if we're actually on. If we did hit a game object, then it figures out the name hash, and that's just because it's easier to pass that to Zig than actually using the pointer of the hit actor itself. Right. So that's now good. I think we should have everything we need on the CPP side. Let's get back to our scene, and we can start implementing this. So let's just make this a pub const Raycast result, and that is going to be a struct, and it will have hit point vec3, hit point normal, which is also a vec3, and a distance, which is a float 32, and then finally a hit game object name hash. Let's just call that game object name hash, and that's a basis string hash, which is actually just an unsigned int. If we go here, we can look at that. I've actually just kind of type def it, if you will, here. But it's good to use this so that it's clear to whoever is reading the code that, oh, okay, that's actually what it is used as. And then I think maybe we can just make a function that will init 0 or something. Raycast result, and it will return. How did we actually do this? Right, so we just return a Raycast result, and then we set these. We need to initialize all of them. So that's going to be 0. I think 0 is fine. And hit point normal as well. What's this? It's just 0. Why does it give me like an uppercase E? That's weird. And then distance is 0. And finally game object name hash is also 0, and a string hash of 0 essentially means like no string hash, and we want a semicolon there. So that's it. We should have the result struct set up for us, and now we can start to actually write this guy right here. Actually, let's just do public function, and we need the self. That's essentially this pointer right here. We need a sphere radius, which is f32. We need an origin, which is a vec3, and a direction, which is also a vec3. And then we need a max distance, which is f32, and then a result, which is a pointer to a Raycast result, and this will return a bool. And actually now I need that bind a lot signature again because I need to make the call. Whoa. Here. So right, so we need to actually create one of these guys. So var, let's call it interrupt result, and How do I actually... You need to create it like this. Let's have a quick look at some of these other... I have like an interrupt matrix 4x3, for example. How do I create one of those guys? Yeah, it looks exactly like that. Right, so yeah, we could perhaps do like an interrupt and to interrupt and from interrupt in the same way that the matrix 43 has, and we'll just actually add them here. So to interrupt would be like a raycast result. That would be an interrupt raycast result, and then we just essentially do hit point equals that will be self.hit. Come on, hit point. There we go. And normal, and distance, self.distance, and now let's make sure we get this right. So it's hit game object name hash is self game object name hash. I shortened that a little bit. And then from interrupt we have essentially the other way around. And that would be just like so. And of course that's going to be one of those, and then we have like that. Okay, so now we have an interrupt result. We should be able to but we actually do, because this is a return value, we actually need to create like a zeroed out version of this, right? So let's just do it like this, and yeah, that is probably, I think we have vec3. Here's vec3 to interrupt, so we can do zero, and then we immediately create interrupt versions of those, and the same thing for that one, and then this is just 0 0, and that is 0. Like so. Yeah, the Zig formatting doesn't like empty lines. I tend to save quite a lot, and it always formats it, removes those lines for me. That's why you see them disappearing and reappearing. Okay, so now that we have this guy, we should be able to just call const was hit or something like that, and then do physics scene sphere sweep, and we'll do self.cpp pointer. That's the first one. Then we have the sphere radius, which can just pass through. We have a few more things here that we need to fill in. So we have const O for origin, so that would be vec3 to interrupt origin, and const direction to interrupt direction, and then we'll pass them as pointers, so the address of O and the address of D, and then max distance can be passed straight through, and then finally address of interrupt result. And maybe we'll actually stick to our region. I'm just call them origin, interrupt direction, and interrupt result. Something like that. The order would be that. Right, and now that we have this, we need to return. Return was hit, but if there was a hit, before we return it, we set this. I think we can do this. We can, like, that's dereferencing a pointer, and we can just assign it raycast result from interrupt result. I think that should work. I'm not sure. It remains to be seen. So we fill up like an empty result for the C++ side to fill in. Then we make the call, and if we did get a hit, then we're taking whatever is in here and assigning it to whatever the result is pointing to. Like that. I think this probably doesn't work, right? Well, it actually does build, but I think that's the more correct way of doing it. So let's do it like that. Okay. So now we should be able to do the sphere sweeps, and actually, I think we can pretty easily now add this to the linear projectile component. Let's add like a let's do a sphere sweep radius, and we'll do what was the actual size of this projectile? So along the x-axis we have dimensions 0.3. Okay, so that would mean that it's like 0.15 is the radius for this guy. And then const sphere sweep hit distance epsilon. So epsilons are typically sort of thresholds or like limits. When something reaches that, then we do something. So in this case, when the hit distance reaches, shall we say, 0.2, those would actually be semicolons. When we do have a hit and the distance is 0.2 or smaller, then we will register that as a hit. Okay. And let's add a function that does this testing. So the first thing we'll do is just make it so that the projectile is removed from the world, and then later we'll make it actually report hits to other parts of the game so that we can apply damage and whatnot. And I think probably the best way to check this would be right after we've set the position to the new one. So so let's make this a function. Check collisions, and we can just feed in the current position here so that we don't have to calculate it again. So current position, and that would be a vec3, and let's make this void, like it can handle internally whatever it needs to handle if there is a collision. And to be able to get the raycast set up, we need the physics scene. And to get the physics scene, I think we have a function here in the primary physics scene. Yes, in context. So I think we'll actually, what we'll do is we'll get that when the object is created, and then we can store it so that we don't need to actually request it all the time. Let's see how are we actually using this. Yeah, we don't seem to be using it currently. I think we were using it in the slide stuff. The reason I'm checking this is that I don't think the scene has an init0 function, which means that we can't really initialize it to 0. Just want to see how we did it here. That's a scene node, but that's not the same thing. The physics scene, okay. And don't we need to actually initialize that? Okay, we do, but we can initialize it here, right here in the init function. So that will work. Okay, well let's do that then. That looks fine. Yeah, because the physics scene will definitely be available when this object is created. Yeah, we don't have to worry about that. Cool. So linear projectile component. We can just we can do this. Scene is right there. And while we're at it, let's do the Raycast result as well. So like that. And then we can do physics scene. Actually, this is kind of almost related to the context, so let's just get it there, and then we can do this. And now we have the physics scene available for us to use. And we need the result, and it needs to be writable. So let's do like sweep result, something like that. And that is a Raycast result. And did we make an init for it? Init 0, yes. So Raycast result.init 0. And then maybe we have everything we need for setting up the call now. Yeah, max distance is the only thing we haven't specified, but we can just put in a very large number and kind of forget about it almost. So const, let's call it hit, and we do self dot. Oh, we need a self one parameter. I tend to forget that. Yeah, self dot physics scene and sphere sweep, and we'll do the radius thing that we set up here. So sphere sweep radius, and the origin is the current position, and that direction is the forward direction which we have as a member. Max distance is something very large, and just to be very clear about our intentions here, let's just call distance and set it to like a large number like this. Actually, maybe it would be more appropriate to use the F32 max here, and that would like that tells quite clearly what we mean. And then we'll pass the address of sweep result. Right, and if we have a hit and sweep result dot distance, I think it's called distance, is less than or equal to our distance epsilon. Then we will want to actually destroy ourselves, so to speak. And how do we do that? Well, I don't know. Can we even do that yet? Game state is the thing that manages the creation and destruction of objects. And yes, we can do it. Excellent. So if we go here and we destroy the parent object of this component. So let's do self context, and then we need to get the game state actually. So let's do var game state equals self context get game state, and then with the game state we can destroy game object, and we need self, yes, and then we need the name hash, and we can do const parent name hash. That's self dot context dot parent dot get name hash, I think. And that should really be everything we need to get the projectile to stop whenever it hits something. std debug warn, I should really learn that. So let's do std debug warn and do like boom. And we can even print the name hash here, just so that we see that it's valid. So that would be parent name hash. This construct here where I wrap this in like braces and a period, that's called a tuple, and it's essentially like an ordered list of things, and this warn is expecting a tuple, so that's why you always need to wrap it here. Okay, and now then okay. No Raycast result. It's probably because we don't actually expose it like that. And we have a physics.zig here, yes. So we need to essentially do this thing. So actually physics scene is where we want it, but we want to have like a pub const raycast result, and then it's coming from the physics scene module and then raycast result, and I think that should solve this problem. Now we have another problem. Let's go to the scene. Oh, we have it right there. And what does it say? Expected type vec3, but we did give it an interop right here. Okay, yeah, of course. So here we're creating an interop, and we have like the normal vec3. So. This just gives returns 1 by value. Yeah, that should be fine. So scene. So this would be 2 interop, and same thing here. And here we have an interop, and so we want to have like vec3 from interop instead. Like that. like I mentioned previously, I'm not exactly sure the interrupt stuff is needed. Like Zig is developed quite rapidly these days, so I think the C compatibility gets better and better all the time. But this allows me to have slightly different looking APIs on C++ and Zig side, so I kind of actually prefer to have these interrupt types in between. The performance differences should be very small. Okay, cool. Let's do a little bit of cleanup there, and actually, I think we'll disable this spawn enemy right now. This should give us the opportunity to test out the projectile logic in peace without having the enemies bothering us all the time. And there are a few enemies in the level when you start. You just have to get rid of those. Actually quite a lot. Let's kill them all. I need to probably put in something here to just destroy these guys in one go. Anyway, let's fire something, and it doesn't work. Okay. Did we actually call that? I'm not sure we did. I'm not sure we did. Okay, well, let's have a look. Right, so what did we call it? We did call it check collisions. Yeah, we don't actually call it. So that would be why it's not working. Updated position is what we want. And now we'll see, yeah, this is exactly what I was expecting. Now we get some compilation errors, because now we're actually using this, so this gets like properly compiled now. Oh, that was me missing the self, so that's the only problem we had. Yeah, okay, so we actually didn't have any more mistakes in that function. I can actually see us doing this a few times, so let's add. Just hide that. Let's add a small script to our level, which lets us get rid of those guys. So we have these guys here, and yeah, how do we actually? Well, the easiest way to do this is just to add a script here, which allows us to kill all enemies. And we can do destroy game object, and this would be base. No, it's called, what is it called? Level objects. Base. Enemy character base 1. And then we have, how many do we have? We have 8 of them. We can of course construct these names procedurally and do like a for loop or something, but I'm lazy now, so something like this, and so to be able to call this easily, we'll just add a dev attribute to it. And now if we export, we can go here and just run script, kill all enemies, and boom, they're gone. Hello. Okay, so now yeah, okay, so we immediately run into a problem. As you can see, when I press the trigger, fire a projectile now, it immediately blows up, and that's because you can actually even see it in here in the screen for a little bit, and yeah, that's because it hits the character itself. So that's not good. That is not good. Yeah. Now we can of course add a filter to the sphere sweep. But let's not do that. Let's just get on with our lives and put in a good old hack to get around this thing. So player name is player 0. This is the thing that we changed earlier here in the game master configuration, game master component. We added this here. So player name is player 0. This is just to verify that this is the problem. Player name, and we have a player name hash, and that would be, I think, basis string, and what do we call it's make string hash out of player name. And so if sweep result dot hit game, or what is it? I think it was game object name hash is not the player name hash, then we do a boom. Right? Does that make sense? A nicer way to do this would be to actually filter out that collision on the raycast or the ray sweep level. But now we can see that it actually does collide with things. Yeah. How about that? It should also collide with the enemies. So now, without running that kill all script, let's make sure that's the case. So, yeah, come at me, bro. Okay, so the only thing we actually need to do now to actually kill those guys is, of course, to just do this. And if we re-enable our spawning logic here, which, if you remember, we'll try to keep the enemy count in the level at 10, then we should actually have all the logic required to kill off enemies, and then have the level repopulated, and it works. So if we run around a little while, the enemies will appear. They will always appear to the northeast of our character, which is annoying, and we'll probably tackle that next. But yeah, now we can kill them all, and you can see the count going down here in the debug output. Fuck you. I probably shouldn't say things like that on YouTube. Yeah. Okay. Isn't that cool? Oh, actually, there's a bug in our system. Can you see what it is? Yes, indeed, we can get rid of our, and we have gotten rid of our environment as well. So that's a bit silly. Like if you don't like this ramp, then just shoot the ramp and it'll disappear. It's not actually going to affect the nav mesh, so those guys will be very, very afraid of this one place here, and they try to move around it, as you can see. Can't reach me. Oh Jesus, what? How did you do that? That's awesome. You can walk through walls. Okay, so let's do something about this. That's not good. How do we keep it from destroying the environment? I'm not sure we actually have enough information in Zig yet to handle that. But we probably should. Now let's see if we can do something about that. So we have the Zig interrupt. Here's the C++ sphere sweep. So we get a hit actor, or we might get a hit actor. And if we get a hit actor, it's a physics actor pointer. And physics actor has a type. Right. Yeah, we could return this thing. And it has this character controller type, which I think we actually already have on the Zig side. If we go here and we look at actor, we actually have that there already. So let's do that. Let's add the physics actor type to the result. So what we'll want to do is add another int32 here, hit actor type, and yeah, I think that's all we need. Maybe we'll call it physics actor. Hit physics actor type, and of course we'll have to jump through a few hoops here in the scene, because we now have it here as well. So this, I think, should be the enum directly, so that we can, like this guy here, physics. Well, that's material. It's physics actor. Physics material. Oh, come on. It's right here. I keep looking at the wrong view. So this would be basis. I think it's physics, and then it's scene. No, physics scene. Let's actually just forward declare that as we did with this. So that would be pubconst physics actor type equals physics actor dot physics actor type. It's probably not called forward declaration because we're not in C++ now, but whatever. Or type diffing or anything. I don't know what to call that actually. So basis, physics, and physics actor type. And then what do we have? So we need to initialize it to something, right? It doesn't have a none. So since we don't have anything better, let's just do hit. Oh, actually just we remove the hit from there. Let's just call it physics actor type. So dot physics actor type equals physics actor type dot rigid body dynamic. And in the interrupt type, it's a uint32. So here, if we go to ziglang and learn and language reference, we have something like enum2 int. Except that we actually want it to be like an uint, like an unsigned int. Cast, int cast. Convert an integer to another integer. It's getting the same numerical value. Right, okay. Okay, so let's see what we have. This is going from an interrupt to the native, if you will, type here. So physics actor type, and that's going to be, first we'll want like int to enum. So we want the destination type and we want the int value. Okay, destination type is going to be that guy, and then we have an unsigned int, and we want it to be maybe it actually does work, since this is actually set to be an unsigned int. So let's try just doing oh, sorry, I'm actually doing the wrong way around here. That's supposed to go there when we get to that, but this is supposed to be hit physics actor type equals self dot, no, enum to int. I'll call it int to enum to int, and then self dot physics actor type. Like that, and then here we have the other way around. So we have int to enum, and this would be just interrupt dot. No, wouldn't be that. It would be here interrupt dot hit physics actor type. Okay. Okay, so let's make that happen. Um, 73. Yes. Okay. Okay. Yeah, I don't know what to actually. I don't know what to actually set that to. We can actually just set it to 0 because it's an integer there, and it's kind of supposed to be not like uninitialized. And then 42 found type, expected type, and found that. Of course, it's just the type that we want. Okay, that looks good. And then now that we have that set up, what do we do with it? Yes, we do. We go here. We haven't actually changed anything in the bind-a-lot file, so we shouldn't need to change anything there. But we'll still have to fill in the value, the actual call. So this would be result hit physics actor type, and we can just, I think here we can just cast it to uint32, and it would be res dot hit actor get actor type. Like that. Yeah, C++ is a little more straightforward to cast between ints and enums. Okay. So can we actually print out the actor type somehow conveniently from Zig? It sounds like something that Zig would be good at. Let's do that. Let's where do we want to do it? I can just do it here. Let's see if this works. I haven't tried it. So debug warn hit type, and then we would do dot make a tuple and have it as sweep result dot physics actor type, and we'll want the new line there. Like this might work, or it might crash, or it might give us some garbage output. Hey, that's cool. It does actually show the right thing, and it does actually give us what we want. Right. So when we're firing a projectile currently, we can look at in the debug window that like it hits a character controller a few times, and that is of course the player character controller. If we're running in the same direction, then it hits it probably more times than it otherwise would. Okay. So if this guy is, let's see, if we have a hit and the distance is small enough, and this is something that we haven't imported here probably, but we can do it. So physics actor type character controller, right? So only, oh no, that's not right. Yeah, because now it won't, yeah. I'm sure you saw that before I realized it before I did. We always want to do this. So if we have reached this place and what? Okay, maybe that is the correct amount. Yeah, it seems to be. Right. So if you got this far and the hit actor is a character controller, then let's kill them off. Otherwise, just go boom and kill yourself, which is here. Now it should be what we want. Right, so shoot. That doesn't do anything, but we can kill these guys off just fine. Okay. So that works. After a little bit of enum fudgery. Okay, yeah, I'm a little annoyed at the poor spawning system that we have going. I think it's kind of keeps it from being truly interesting. So let's perhaps tackle that in the next video. But this is nice. We already have working weapons. I need to do something about that. Because now we have this hard-coded player 0 here, but we can figure out how to deal with that. Maybe I think whenever we spawn like a player component like this, no, actually whenever this becomes an avatar, we should probably register that game object with the game master, and then you can ask the game master, like, hey, is this guy actually a player? And another way would be to, like, when we have this hit game object name hash here, we could actually like check if an object with that name hash actually has a player component, and then we know that, okay, it's a player. And of course, the reason why I don't want to do something like this is that if we have a multiplayer game, then player 1 would be the second player 0 and then player 1, and then this check would fail, and that would not be good, because then player 1 could never fire anything without killing themselves immediately. Okay, I think we'll end this video here, and we'll get to probably all of this in the next video. We'll see what happens. Thanks for watching as always. I hope this has been interesting, and yeah, this game is already kind of looking like a game now, so exciting times. Okay, see you later, bye.